We are going to see how to use Fuzzoor to build and run fuzzing tests with Echidna and Medusa. We will do an example based on this article from Horse Facts that I highly recommend you to read. The article shows how to apply invariant testing over the WETH contract using Foundry, but we will adapt it and use Fuzzoor to create tests for Echidna and Medusa. Here it is the project. It is a simple Foundry project that has just one contract. It is a version of the WETH contract that uses Solidity 0.8 and has only these few functions. We can find the Fuzzoor view in the Explorer view container. In order to get the contract's data, we have first to compile the contracts. So we will do a forge build and press refresh. Now we can see the only contract of the project and all its public non-view functions. We can select the function we want to build the handlers for, but we will just build the scaffold project for now. For that, we click on the Build button, and all the files are created. Let's now break down all the files. Here we have a README file with the file structure and a description of each file. The actor contract is used to represent a user or contract that interacts with the target contract. It has some helper functions and support for receiving NFTs, and you can add to it any extra logic you need depending on the project you are targeting. The config contract defines the addresses that Echidna and Medusa use to initiate the transactions, and they will be mapped each to an actor contract. It also defines the values of the initial ether and token balances that the actor contracts will have initially. The base contract contains first the ghost struct that can be used to keep an internal track of the state variables and compare them with the actual state of the variables in the target contract. Then it contains the global variables for tracking the different actors and a modifier that maps the transaction origin to one of the actors. The contract section will declare the different target contracts of the system that will be automatically generated by Fuzzoor. In the setup function, the target contracts and initial setups are defined, and in the setup actors, we initialize all the actors. Finally, we have some helper functions to perform some operations related with the actors. The snapshots contract is a helper contract that we can use to take snapshots of the state of the target contract before and after a certain action and compare them. The properties contract is where we define the properties or invariants of the system. The global properties are those properties that should hold at any time, and we have to include them in the global properties modifier. Specific properties are those that should hold after a certain action, and we should call them from the specific handler function where we want to check them. The handlers contract is where we define the functions that will interact with the target contract. These functions will be generated by Fuzzoor, but we will usually require to adapt them or add some extra logic. Then we have the fuzz tester contract, which is the entry point for Echidna and Medusa, and we will usually don't need to modify it. Foundry tester is a contract where we can run specific tests or debug failing properties very quickly using Foundry. We have also some helper contracts for cheat codes, assertions, logging, and some other utilities. And finally, the echidna.yaml and medusa.json files are the configuration files for Echidna and Medusa, respectively. So now, let's start by building some handlers for the deposit and the withdraw functions. We just select them and click on the Build button. The two handler functions are added to the handlers contract, and the target contract is also declared and instantiated in the base contract. Each handler function includes two modifiers. The useActor modifier maps the transaction origin to one of the actors and assigns it to the actor variable. Then the call to the target contract is pranked with the actor address. The global properties modifier is used to check all the global properties after the target function is called. As deposit is a payable function, Fuzzoor automatically clamps the value sent between 0 and the balance of the actor. We expect the withdraw function to fail if the actor tries to withdraw more WETH than its current balance. So for this test, we can clamp the WAD parameter between 0 and the actor's WETH balance. Now let's create a failing global property to check that all the setup is in place. We create the property and add it to the global properties modifier. To avoid waiting too much time for the fuzzing campaign to finish, we will adjust the configuration parameters. First, in echidna.yaml, we will reduce the test limit to 5,000. This is the number of sequences run on each campaign, and set stop on fail to true, so that the campaign stops as soon as a failing property is found. Now in medusa.json, we will change the test limit to 50,000. Note that in Medusa config test limit is the number of function calls and not sequences. And then we set stop on fail test to true. Now let's run Echidna. To do so, we just click on this button and a failing property is found, as expected. Now let's run Medusa. We click on this button and the failing property is found again. We can see the full reports here, and also the report for a specific contract. As this project has only one contract, there is no real difference though. Now let's write a real global property that verifies that the total ether balance of the WETH contract is equal to the sum of the WETH balances of all actors. We create the property and include it in the global properties modifier. Now let's run Echidna again. And the property holds. Let's now run Medusa. And the property holds again. Now let's create the remaining handler functions for approve, transfer, transfer from, and the fallback function. We will make sure that we only approve other actors, so we can use the helper function to actor address not current that will choose a random actor different from the current one based on the input address. For the transfer function, we will also make sure the destination address is another actor and the amount sent is not greater than the sender's balance. For the transfer from function, we make sure that both the source and destination addresses are actors and that the amount sent is not greater than the source balance and the allowance to the current actor. Note that while bounding the values of the parameters makes the test more efficient, we are also introducing some bias. So you should be careful when setting these bounds, and is always a good idea to run some tests without them. We run echidna, and our property still holds. Let's also see the new coverage after this changes. Now all the functions are covered. The next step will be making sure that the WETH contract's ether balance is always enough to cover all possible withdrawals. For this, we will use ghost variables to track the total amount of deposits and withdrawals and check that at any time the ether balance in the WETH contract is equal to the total deposits minus the total withdrawals. We first add the deposit sum and withdraw sum ghost variables to the ghost struct in base.sol, and then update their values in the deposit, withdraw handlers, and also in the fallback handler, as it offers a different way to deposit ether in the WETH contract. Now let's create our new global property. And include it in the global properties modifier. We will run Medusa this time, and the property holds. The last property we will write will check that after a deposit, the total WETH supply increases by the amount deposited. For this, we will use the snapshots contract to take a snapshot of the state before and after the call to the deposit function and compare the values. We first add the total supply variable to the state struct and update the underscore take snapshot function to save the value of this variable at the time of the snapshot. Now in the deposit handler, we call to the snapshot before function before the deposit and the snapshot after function after the deposit. We will now create the new property. This property will take as parameter the amount deposited and will check that the total supply increases by this amount. Now we call this property function at the end of the deposit handler and run echidna. And all the properties hold. There is yet one way of sending Ether to the WETH contract that we haven't tested yet, and that is by calling self-destruct on a contract to force send all its Ether to another contract. Fuzzoor allows to include an extra function that will force send Ether to the target contract. We just have to make sure this option is selected in the extension settings. So we enable the force sendeth option and press the build button. Now we can see the new handler function that will force send Ether to the target contract. Let's now run Echidna. And our solvency balances property fails. This is because the Ether sent with self-destruct is not accounted for. So we will create a new ghost variable called force send sum and update its value in the force send handler. Now we account for this value to the solvency balances property. And also in the solvency deposits property. And run Echidna again. Now the property holds. So, that is a brief example of how you can use Fuzzoor to build and run fuzzing tests with Echidna and Medusa. I hope you find it useful and that you can apply it to your projects. Thank you for watching.